Cities aren't just collections of concrete and glass. They're living organisms shaped by ambition, necessity, and innovation. But as we look toward the future, I have to ask, will our cities soar, sprawl, or even leave Earth behind? Imagine if you could design your perfect city. Would it look anything like what we see today, or something far more extraordinary? Let me tell you, when I was born in 1980, the world's population hovered around 4.4 billion. By 2020, it ballooned to 7.8 billion. That's not just more people, it's denser living, taller skylines, and far more complex cities. Urbanization, a technical term for the movement of populations into cities, has fundamentally shifted how we live. Now, you might be thinking, are we headed for a green paradise or a cold, crowded dystopia? That's the conflict at the heart of future urban life. Do we double down on nature or tech? The answer isn't simple. It's a question of choices: where we build, how we build, and for whom. So, as we launch into this exploration, I want you to imagine yourself as both architect and resident of tomorrow's city. What would you prioritize? Today, let's set out on a journey across the cities of tomorrow, from the familiar to the fantastical, and uncover how they might reshape not just our environment, but the very fabric of our lives. Have you ever wondered why cities seem to grow upward instead of outward? Urban density and sprawl, those are our first technical terms capture the tension between building tall and building wide. When cities grow, commuting distances don't just double, they often quadruple, thanks to geometry and what urban planners call the radius of average travel. Picture two random points in a city. The average distance between them is nearly half the city's diameter, a hidden cost of sprawl few consider. And as more people pack in, congestion and commute times skyrocket unless transportation keeps pace. Now, you might be thinking, why not just build vertically? That's the promise of skyscraper-staller buildings: mean less ground covered, shorter commutes, and theoretically more green space left intact. But here's the conflict. Taller buildings require exponentially more resources and complex engineering. The resolution? Innovations in construction materials and automation could make vertical living not just viable, but desirable. So, as we grapple with the tug-of-war between density and comfort, let's ask ourselves, are we willing to invest in technology to make our cities not just taller, but better for everyone? Let's take a ride literally into the heart of the vertical city. Elevators, or vertical transportation systems, sound mundane, but they're the unsung heroes of skyscraper life. Imagine living on the 150th floor. You press the elevator button and wait. And wait some more. If you think traffic jams are bad, try an elevator at rush hour. Here's the technical twist. As buildings grow taller, more space is needed for elevator shafts, and at a certain point, they consume half the building's footprint. Now, you might ask, why not just add more elevators? But the more you add, the less usable space you have. It's a paradox, a classic architectural bottleneck. But there's hope. The resolution lies in express elevators, decentralized layouts, and sky bridges innovations that break up the vertical gridlock and turn mega towers into self-contained neighborhoods. What would life be like if your commute was a quick glide across a sky bridge rather than a cramped elevator ride? That's the future we can design if we dare to rethink the basics. Let's zoom out from the single skyscraper and picture an entire ecosystem under one roof. Arcology, combining architecture and ecology, is the technical term for these megastructures where people live, work, and play all in one interconnected space. Imagine a building so vast it houses 0 people with homes, shops, schools, and even indoor forests. Sounds utopian, right? But the conflict emerges when we consider the square cube law. As buildings grow, interior space increases faster than window area, making much of the inside less desirable. Now, you might say, can we really live without sunlight? Well, designers are getting creative: interior parks with artificial lighting, hydroponic farms scrubbing the air, and even digital windows simulating the outdoors. The resolution? By integrating vertical farming and green spaces, arcologies could become self-sustaining mini-cities, resilient against food shortages or supply chain shocks. Let me ask, would you trade a garden view for a digital sunrise if it meant never needing to leave your building? That's the leap arcology asks us to make, and maybe, just maybe, it's the future of sustainable city life. Raise your hand if you've worked from home in the last few years. Remote work and digital infrastructure, next technical terms are reshaping how and where we live. No longer tied to an office, millions can now choose communities that fit their lifestyles, not just their jobs. But here's the conflict. As more people work remotely, the classic model of sprawling commuter cities is being challenged. Some worry about isolation, while others see a return to tight-knit neighborhood suburban villages where people live, work, and socialize in the same space. Now, you might be wondering, won't this just lead to more screen time and less real connection? The solution is hybrid, blending digital connectivity with real walkable communities. Third, space cafes, parks, libraries become vital for social health, giving us places to meet outside home and work. Let me tell you, even out here in rural Ohio, I feel more connected than ever to major cities. The future isn't about choosing city or country, it's about designing cities with the flexibility to let us choose both. Every city has its ghost abandoned malls, shuttered factories, forgotten subway tunnels. Adaptive reuse and urban resilience are two technical terms that describe how cities can turn yesterday's ruins into tomorrow's opportunities. Think about Toronto's underground path or Montreal's Resouver 30 kilometers of tunnels transformed into vibrant commercial arteries. The conflict? Old infrastructure is often expensive to retrofit and sometimes no longer fits modern needs. Now, you might ask, why not just build new? But starting from scratch isn't always possible or sustainable. Repurposing old spaces can revive neighborhoods, preserve history, and reduce waste. The resolution is creative thinking, turning empty spaces into parks, apartments, or even urban farms. Cities that learn to adapt thrive, those that don't risk decay. So let me challenge you. Next time you pass an abandoned building, imagine what it could become, because every city's future is built on the bones of its past. Now, let's look way up. Space scrapers and orbital elevators are the technical marvels that could one day connect Earth to the stars. Imagine a tower so tall it pierces the stratosphere, serving as a launchpad for cargo and people alike. The allure is obvious: reduced launch costs, scientific outposts above the weather, and penthouses with a view of the planet's curvature. But the conflict is daunting. Structural engineering at this scale means battling wind shear, earthquakes, and the sheer weight of materials. Now, you might ask, wouldn't living in a space scraper be isolating or even dangerous? Absolutely. Emergencies in a 50-kilometer tower aren't just inconvenient, they're a logistical nightmare. But innovation is racing ahead. Smart stabilization systems and modular construction could make these mega towers possible and safe. Are you ready for a future where your elevator ride ends in orbit? The sky may no longer be the limit, but rather the foundation for humanity's next leap. Let's dig a little deeper literally. Subterranean cities and geotechnical engineering offer protection from surface hazards, climate extremes, and even cosmic radiation. Cities like Montreal and Toronto have already pioneered extensive underground networks. The appeal of underground living is obvious: insulation, safety, and the ability to expand without disrupting nature above. But here's the conflict. Natural light and open space are hard to replicate. Artificial lighting, no matter how advanced, can't quite match the psychological benefits of sunlight. Now, you might be thinking, could I thrive under artificial skies? For many, the answer depends on how well we design these space. Can we create underground parks, vibrant markets, and social hubs that make us forget we're beneath the earth? The resolution lies in biophilic design, incorporating nature wherever possible, from mushroom forests to hydroponic gardens. If we get it right, subterranean cities could be both sanctuary and adventure, offering a template for survival on other worlds as well as here on Earth. What if your city floated serenely on the ocean? Artificial island construction and modular urbanism are the technical keys to making floating cities possible. Imagine a metropolis that can migrate with the seasons, powered by solar and wave energy. Life on the water offers endless ocean views, fresh seafood, and a buffer from land-based congestion. The conflict? Maintenance in the harsh marine environment, corrosion, storms, and freshwater scarcity can turn paradise into a logistical headache. Now, you might ask, would these cities just become havens for the wealthy or lawless outposts in international waters? That's a real risk if governance and equity are ignored. The solution is thoughtful design modular neighborhoods, sustainable infrastructure, and legal frameworks that protect both people and ecosystems. If we dream big and plan smart, floating cities could become beacons of innovation, not just playgrounds for the privileged few. Let's take a leap up into cloud cities and down into underwater realms. Aerostat's giant floating structures and pressurized domes are the technical marvels that could make these visions real. Imagine walking through gardens thousands of feet above Earth, or gazing at bioluminescent fish from your bedroom window on the ocean floor. But the conflict is gravity literally. Keeping a city aloft or a dome intact under tons of water is a constant engineering battle. Any failure could be catastrophic. Now, some might ask, wouldn't life in these environments feel like a prison? Small, isolated, always one malfunction from disaster? That's a fair worry. The resolution is robust design, automation, and above all, community. Social cohesion, the glue that holds people together, matters even more in such extreme habitats. Would you trade a bit of risk for the adventure of living among the clouds or beneath the waves? Sometimes, the edge of possibility is exactly where growth happens. Now for the grand finale. Space habitats and planetary colonies, O'Neill cylinders and terraforming are two technical terms that might soon become household words. These are artificial worlds-massive rotating habitats or even entire cities on Mars and the Moon. The allure is freedom, custom-designed environments, new societies, and the chance to escape Earth's limits. But the conflict? Space is hostile. Every breath, every drop of water must be engineered with precision. Now, you might ask, is it worth the risk? What if something goes wrong? In space, redundancy and resilience are life itself. The solution is to plan for failure-layered safety systems, closed-loop recycling, and above all, a culture of adaptability. So, here's my challenge to you. If you could build a city on Mars or in orbit, what values would you embed? Because in the end, the cities of the future will be shaped not just by technology, but by the wisdom and imagination of those who call them home.